distance vector routing table. So how it will update it? So based upon the information which is gathering from the neighboring node, so the each node will update its distance vector. So in this diagram you can see here the station B or the node B is updating its distance vector which has been received from station A and station B. So at every time whenever there is a updation is there from its neighboring nodes, so the corresponding node which will receive the updation from the neighboring node, they will update its whole distance vector. Okay, so this is how it will be done in the distance vector. And this is the algorithm what we have done. So initially what we do is, so the initially when the network has been created, each network will be connected to some other network. So based upon that they will be creating the distance vector. So the first law for loop is to create the distances for the initially when the network has been initiated. So after that what happens? So the each neighboring node will send the information about the distances to the neighboring node. So upon reception of these distances, so we are going to update our link from each node to another node. How? The path, that is the distances between one node to another node, if it is large, and in the updated table it is possible for us to find a minimum distance, means then the minimum distance will be updated when you compare to the previous value. So this is how we are going to update it in the distance vector. So now we are going to make use of that distance vector in the link state routing algorithm. So this link state routing algorithm, so the distances what we used in the previous case, so we will be using, or we will be denoting them in terms of least tree algorithm. Okay, so by the use of this least cost tree, so for each node we will be creating a tree from the starting from the root node. So how the data can be forwarded, how the data has been, how the link has been established from source node to the all the neighboring nodes. So we will be representing in terms of tree diagram, and the tree or the link which has got a minimum the distance value, so that we call it as a least cost. So for that we need to update a link state database. So through the use of this link state database, what we can get is the least cost from each node to the subsequent neighbors which are there for the particular node. So we will be getting this link state database. And this link state database, why we call it as a database, means for each node, so all the corresponding other nodes which are there and the corresponding links which are there available for the network, so all the information is available for the node, for the corresponding node also, and for the neighboring nodes also. So therefore we call it as a link state database. So from, if I say if I initiate a communication from source to destination, means then what are the possible links are there from source to destination? Is there any one link is there? Is there any two link is there? Or is there any four link is there? So the available links will be available in the link state database. So with the use of this link state database, we can able to find the which is the minimum least cost path from source to destination, so that the data can be reached with the minimum cost which has been spent for the data transmission. And which is related to your link state database, you can see here it is a two-dimensional matrix what we are creating. So the first row is nothing but the number of rows, and the columns are nothing but the number of the nodes. Okay, so from each node to the remaining set of nodes, so we will be updating the distances, that is we call it as a minimum cost which is needed to reach those particular node we will be representing. So if a corresponding node, if let's say the node A, if it is not connected to node C directly, means then the distance from node A to node C we call it as a infinity. So for example, you can see here in the link state database, that is A, B, C, D, E, F, G. That is the first row. So that is the distances from node A. So from node A to node A it is 0. From node A to node B it is 2. Why? Because since A node is directly connected to B, so therefore it is 2. And since A node is not directly connected to C, therefore the distances we wrote it as infinity. Similarly for D it is 3, and for rest of the cases, that is for E, F, G, it is infinity only. Why? Because the node A is not directly connected to the node E, F and G, so therefore we call it as an, or we represent them distance as an infinity. So with the use of this link state database, and this link based database will be updated in a periodic manner depending upon the signaling instances what we are going to use in the network. So based upon that, through the use of this weighted graph, we can able to update this link state database. Okay, so how we can create this that is a least state routing protocol, and which has been sent from each node to another node, so that we can able to build a that is a least state database. Okay, so you can see here, so depending upon the information which has been transmitted from the each node, the linked state database will be updated. So from each nodes, the corresponding node will be updating. So you can see here the node B from for the node A. So to reach a node B, the cost is 2. So that is what we are writing over in this diagram. You can see here for the node A, it has been connected to two nodes. One is node B and node D. So the node A with the corresponding cost is 2, and for the node D, the corresponding cost is 3. See, for the time being, you indicate that the distances and cost are same. Generally the distance and cost are different, but for the time being, because we will differentiate this cost value and distance value in the later cases, for the time being you should assume that the distance between reaching from one node to another node, it is nothing but a cost value. So you can see here in the case of node B, so it is being connected for the three nodes. So what are nodes it is connected? It is connected to node A, it is connected to node E, and it is connected to node C. So therefore for the node B, the table which has been created for the node B is nothing but node A is a neighboring node, the cost is 2, and the node C is a neighboring node, the cost is 5, and the node E is the neighboring node with the cost is 4. So like this it will be from each node, that is a state link state information. This link state database will be updated. Okay, so you can see from each node the information which is pertaining to the neighboring nodes. So with the use of this, the entire least state database will be updated. Okay, sorry. Okay. So now you can see the formation of how you do the least cost tree. So now you have created all the nodes. So once you create all the nodes, the next thing is how you select the which one is the minimum path. So in order to select the minimum path, we will be using a Dijistra's algorithm. So this Dijistra's algorithm, we call it as it is a routing algorithm which is used to transfer the data from source to destination with a which is having a minimum cost. So how it will does, or how it will select the minimum cost is, so for that, in order to select the minimum cost, we will be using this Dijistra's algorithm. So the working principle or the process in which the Dijistra's algorithm is work based upon that. So it works based upon these three important steps. So the first one, what it does is, so when a node wants to transmit any data to the surrounding or the neighboring node means, so that node will be chosen as a tree node, or it will be chosen as a chosen as a root node. Okay, so then what it does, it creates a tree with a root node. So what it creates, so it creates a tree corresponding to the all the neighboring nodes. So if a node A is connected to node B, okay, a leaf will be drawn, and what is the cost of reaching from a root node to node B, so that will be indicated. Next, similarly for node C, it will be indicated, node D will be indicated, and node E will be indicated. Okay, so like this, a set of total cost of each nodes based on the information in LSDB will be created for the node who wants to initiate the data transmission. Okay, so now now the next what it does is, a node selects one node that is among all the nodes. Okay, so if it is not present in the tree, which is closest to the node. Okay, so now what it does is, and it adds this to the tree. So now what, in the first stage what we said is, a node is directly connected to the neighboring node means, so those nodes we have already included in the tree diagram. Now the node which is not connected to the root node directly, so that nodes we want to add it to the tree diagram. So how it will add, so it will take it, and which is the closest root for that, so that path, that node will be added. Okay, so after adding that node to the tree, then again the cost of all the others node which is there in the tree will be updated. Why? Because if you add one more node to the tree means, then the corresponding data, that is the source to destination, or the corresponding path in receiving from source to destination, it will changes. So therefore you need to update the path which are associated to the new node which is added to your tree. Okay, so like this, all the nodes which will be added to the tree and the corresponding path. Once you add a new node means then the path will changes. So the cost which is associated for each path will changes. So that has to be updated for every time when you add a node. So like this, you are going to add all the nodes. So when you add all the nodes to the root node, then the root node will have an multiple paths to reach from source to destination. So which is having the least path to reach from source to destination. So that will be selected from this tree diagram. Okay, so this process we call it as a Dijistra's algorithm. Okay, and you have one program which is there in your CN lab. So we will try to see how exactly the root node will transmit the data from source to destination and how it will select the path, that is a path which is having a minimum cost. So all those details means with the implementation or with the simulation we can able to see from the in your CN lab. Okay, so you can see here in the previous, so how it will update it. See, the first time when it creates, for example, for this tree diagram only. So if I want to create a tree diagram for this weighted graph means, so for the first time what I will do is I will create a root node that is A. So I will create a root node this. So it has a two branches. So what are the two branches it has had? It has a branch D and a branch B. Okay, in the second stage what I will do is I will add one more node called as a E. So what I will add one more node for this C. So if I add that means then what happens is, so from A to C there is a path will be established. So that has to be updated in your link state database. Now what I will do, I will add the closest node, that is E is the closest node. So I will add it to the tree. So based upon the distances from this B and D, I will add it and I will update this link state database. Similarly, I will add F to this tree of A. So when I add it, you can see here, you can reach from A to F in this direction also. You can reach from A to F in this direction also. And you can reach from A to F in this direction also. So which one is having a minimum path? No. So for that path, the node F will be added. So similarly, the last one is G will be added. So when you add every node to the corresponding root node, the path which are associated to the new node will changes. So that path has to be updated in the link state routing algorithm, or it has to be updated in the link state database. So that is how your Dijistra's algorithm will work. The next one is the path vector routing algorithm. The next one is, we call it as a path vector routing algorithm. So still now whatever we discussed about the distance vector routing algorithm or a Dijistra's algorithm, so there is no criteria in selection of the path. So the criteria for selection of the path is based upon the cost only, based upon the cost only. But if you are doing your routing algorithm based upon the path only, then some of the security measures or safety measures are violated in the case of least cost routing algorithm or a distance vector routing algorithm. So those drawbacks which are there in the least cost routing algorithm or in the distance vector routing algorithm, that has to be minimized, or we need to come up with a new routing algorithm. It is not only the cost is associated for data transmission from source to destination. So there are several other factors we need to consider when we go for the data transmission from one node to another node. And also in the case of Dijistra's algorithm, so when you add any node, when you add a new node to the existing network means all the neighboring has to be updated. Since when you add a particular node to the neighboring, when you add a new node to the existing network, only some node will the path will changes. It's not that all the paths will changes, only some node will be changes. But in the Dijistra's algorithm, if you add a new node for the existing network means, then all the nodes has to update its routing table. So that is a what we call it as a redundant work which has been doing in the case of your disastrous algorithm. So we want to minimize those effects, and therefore we have come up with a path vector routing algorithm. So this path vector routing algorithm, it allows to reach the packet from source to destination with the safety measurements, and you make sure that the path what you are going to assign, so they are more efficient to transfer the data from source to destination. So that is how your path vector routing algorithm will work. Okay, so now you can see here for each iterations the path vector routing algorithm will be updated. So you can see here, so initialization phase. So when the network has been created, so let us consider a root node as A only. So means what, we want to create a root. So from in order to create a root, so we need to create a starting address or a starting node we need to select it. So for the starting node what we are selecting is a node A. So from node A you can see here the distances or the closest nodes which are there for node A is nothing but A to B and A to D. So I will create a path from A to B and A to D. So that is the first initialization path what I have created. So among this you can see here the from A to D, A to B and A to D. So you can see the cost which is associated to B is 2, whereas the cost which is associated to D is 3. So among this, which one is the first cost? So that is the cost is first one is nothing but A to B is the minimum cost. So therefore I will select that path. Okay, in the second iteration now, which is the closest node for node A, as there is only one node which is closest to node A, so it will select node D. So in the second iteration, a path has been established from node A to node D. Okay, so that is how you have created a next. So next what we will do is in the third iteration, so is there any node which is connected to D? No, we will not get it. So is there any node which is connected to B? Yes, there is a node which is connected to B to E. There is a link is there. So therefore I will update in the iteration number 3. Now in the iteration number 4, so from B to E there is one link is there, and it is a minimum when you compare to the remaining link. So therefore the link has been established between B to C in the iteration number 4. And the iteration number 5, now what is there is a link is established between E to F. So therefore in the iteration number 4, so that will be updated in this iteration. And finally in the iteration number 6, all the nodes, that is there is a link has been established from F to G, so therefore a path has been created, so that path has to be associated with this node. So means what, at each iterations if a new link has been established means then that will be updated in the case of your path vector routing algorithm. So in your path if any node is appear means then you are going to include that path in your from routing from the root node. So that is how you are going to see here. So you can see here the black color, it is the root node, and the node which is there in your path. So the node which was there in your path is, that is nothing but the first case B, and in the second case you had a B and D, and you can see yellow white color node, it is not yet in the path. And here the potential path, so means what, there is a possibility of path between B to C and B to E, so therefore we call it as a potential path. And the solid line is nothing but the link has been already established. Okay, so this is how we are going to do the iterations in the case of the looping problem. Okay, so when HOD sir was discussing about the looping problem, so we can able to avoid this looping problem by the use of this spanning tree. So here also we are going to use this spanning tree. So when you are going to have this spanning trees, see when there is a multiple path which are available from source to destination means, then which is the path we need to select. So in order to do that we will be using this spanning tree. So you should not see that the path which has been selected in the spanning tree, it is not the minimum cost. So first thing you need to do is that in spanning tree algorithm, if you have a 2 to more links, means it is something like a circular manner you will be having a feedback we will be having in the such as instances. So in such a cases you are going to select a that is a path which is depending upon the policies which has been determined by the network. So it is not the minimum cost we will be selecting among the n number of paths. So the paths will select best for the policies which has been imposed by the source. So based upon that the route will be selected. So once the route has been selected, then the data can be successfully transmitted from a source to destination. Okay, and there are the source may apply not only can apply only one policy, or cannot impose only one policy. It can have several policies to be employed when it is choosing a best path from source to destination. See, one of the policies is this: which one is a minimum number of hop, so that I can select it, or which one is having a maximum the energy level which is there in the node, so that I can select it. That might be one more policy. Or which one is the path which is having a stable path, means from the previous duration of time, for a certain instant of time the path should not be changed, so that path selection might be one of the policies. Okay, so means what, the source will generate the path, and based upon the source what policy it is going to employ in order to selection of the multiple number of paths, so based upon that the path will be selected. Okay, so as I told you, the policy is that, so it might be the minimum number of hop count. So from, if I want to reach from source to destination, if minimum number of nodes has to be there in the intermediate, means then we call it as a minimum number of nodes, or we call it as a minimum cost of the minimum cost of the link, we call it as. So one more link is, as I said you, so if the nodes, if they are not changed their positions, so that path you need to select it. Why? Because that path, it indicates that the stability of the path will be more. So even when you transmit the data, so in between the intermediate node will not change their position, so therefore the data can be reached from source to destination in a quicker manner. So in order to do this, all these mechanisms, or in order to employ all these policies in the selection of routing table, we are going to use this spanning tree algorithm. So you can see here the spanning tree algorithm, how you are going to use it in a path vector routing table. So you see here you have a network, that is an internet network you have. So where the node A is connected to B, and this is the architecture of the network what we have taken. Okay, so now you can see here the loop has been created over here. You can see here the loop has been created over here. So what is the loop? From A to B, from B to C, C to D. So that is a one loop, and from D to C and C to E, that is one loop we can say. And one more loop what it has this, from B to C, C to E, E to D and E to B. So this is one of the loop what we have created. So now what we want to do is we want to avoid this looping problem. Why? Because there are multiple number of paths are there. So it will be a confusion, or it will be not an ideal method to select the routes. So in order to avoid this looping problem, what we have come up with, we come up with the spanning tree. So in order to avoid this spanning looping problem, so you can see how we can create a spanning tree for the node A. Okay, so how it can create, so from A to B, so then there is a link is there, so there is no loop has been created, so it is as it is. From B to C, yes, there is a no looping is there. From B to D, there is a no looping is there, but there is a loop is there from C to D. So what I will do is I will eliminate this link. Okay, I will eliminate this link, so therefore you will be getting a spanning tree for the node A. Similarly, for the node B, you can see here, for the node B, B to A there is a link is there, and B to C there is a link is there, and B to D there is a link is there. But from C to D, means since B is connected to C and B is connected to D, so there is no necessity for you to have a link from C to D from the point of node B. So therefore I am avoiding this link. So that is nothing but C to D, I am avoiding link, and from C to E, that is from D to E, there is a link is there. So that is the link what I am establishing. Okay, so this is the spanning tree for the corresponding node B. Similarly, for the node C here. So node C how? So it is have a path from B, it have a path from C, and it have a path from D. Whereas it does not have a path from A directly, but it can go from B to A it can reach. So therefore C to B is there and B to A is there. So this is the spanning tree. So we have avoided the looping problem. So you can see in the D spanning tree how it is there. So from D to all the nodes which are connected. So therefore I will connect it directly. So B is there, C is there, E is there. So I have connected. And since there is no path is there directly, so I can reach this D through B node. Similarly for the E path, so you can see here E to C, C to D, and B and A is there. So means what, we have avoided a looping problem in the routing table. So if you avoid this looping problem means then the duplication of the routing paths which are there from source to destinations will be avoided. We will be having a less number of paths to select. So if you have a less number of paths are there for you to select means, so the path which is having a minimum means the number of nodes, or which is having a larger average energy of the nodes means, so based upon the policies which are governed by the path vector algorithm, so that we can employ in the spanning trees of the nodes. Okay, so this is how a spanning tree will be created in a path vector to avoid a looping problem.